Okay, so check it out. I wanted to make another video this week just to bring your attention on the videos that we have of the stars, and there are a few things that are important to know about those videos about the stars that we managed to film. Is that there are lots of anomalies. There are lots of things that are not normal. There's a lot of activity there. It appears to be a lot of electrical activity, if we can say like that. Um, but nevertheless, the last time we saw the pictures of the stars we took, we saw also pictures of a the what appears to be a texture between the star uh, and the skies and space, if you want to believe like this, but meaning that there is a texture behind the stars, and it seems to us that at some point, the stars do reflect themselves onto that structure there. So we saw that last time, and today we're going to analyze that a little deeper. So here's a video of what we saw last time. So here it goes. And I wanted you to to know what's going on, and to maybe to come up with some ideas. So those are the stars that we saw last time. This is Sirius. Okay. Um, that's what it is. And you see that there are some things around the stars, some kind of activity and lights that glow around the star that do not apparently belong to the shape of the star. Something else. So you see this lights there behind. So this is Tajan, and now I invite you to look closer. So check it out. So this is, the star, Sirius. Okay, I zoomed on the that picture of how do you call it? That rainbow style, type of reflection that's behind it. And you see there are holes. You see there are holes that form up, and I don't know if it's a distortion of some kind of plasma. I don't know where it is. I don't know if it's reflects some kind of a, you know field. I don't know, but this is what we have to observe. There are holes being formed, and then they disappear, and then they come back. You see, so this is what I wanted to show you, and then we'll discuss a little more about what it can be. You see, these are the holes. There are many more, but I just just wanted to bring your attention on a few of them, most obvious ones. So here we go again. We have holes forming all over the place. See? Boom. Okay. So I wanted to share that with you. We're gonna see more. Here again, all kinds of holes. And here we have a special shape there. It's not a hole, and it forms like there are straight lines and and right angles there, if you can see. So it's strange to see that a soft matter like this, like something watery, something like, can even for a split second show like, right angles and straight lines, you know, because it looked at first like, like the reflections of sometimes on of the sun on the waters, on the waves there, on the sea. But you won't never be able to see, I believe, shapes like that. So the light there is behaving like kind of funny. And you see here, there's a comparison between what we just saw, the straight lines, and then a few seconds later, up you have this is the same thing. You see there is like three, like looks like 3D, type of balls there or cones there coming up towards us. But this is the difference between the two pictures. Now, here we are. So now that's the most important thing. You see where in that circle there, you see there is some kind of a cone like this and with stripes. And this is proper to the shape of the stars we've seen so far, that cone there, and there are stripes. Sometimes you can see them like turning, but that's the pattern, in those stars is there is a cone with stripes, and sometimes, we can detect like some kind of a vortex going on there. Okay. So here, what I believe it might be possible, but I don't know, I just wanted, your opinion about that, is that actually this this reflection here, if I can call it like this, if it is a reflection, we still don't know, might be in fact the reflection of that cone there from that star. So now you can see that we see stripes there, but you do not see stripes on the cone there. But since there's another surface, it's possible that it catches stripes over there, because stripes are coming back after that. Just let me show you so you understand. So you see, then the star disappears, and you see here, you see the stripes because now it doesn't glow anymore. You can see the stripes real clearly. And here you understand this is what we just saw. Just superpose the pictures. You see, this is with the stripes there. And here we see those stripes there. And I even believe, I don't know if you can see it well on the computer, but on the phone it comes up much better than that. It seems that here also we have like some kind of cone with a few stripes, but it's very, very faint. It's not easy to detect, especially on the computer. On the phone, there's a much better resolution. So those are the pictures I wanted to share with you at first, and then we'll discuss. Same thing, holes all over the place, holes moving. And you have to know something, it changes every frame. It's like every frame is a different texture, different appearance. So it's not like okay, so here we go. Here we are. I wanted to just come back to that because video goes fast here. So check that out. This is very important and very interesting. If what we see is light, you can see blue light, reddish light, it doesn't behave like normal light. Why? Because it does not spread out, you know, like a halo of light. It doesn't spread out like evenly all around. And it stops uh, on a straight line. So you have straight lines where the color blue is going to stop on that line there. And then there's another line at the bottom also, it stops. So it's like the light is forming like straight lines, like so that there is something that that's going on there. Check it out. You're gonna understand better. You see, here it stops and here it stops. The light does not go around, around like in circle. You understand? Also, the reddish one, on the top right, you see it's like straight. The light here on Earth doesn't behave like that, really, unless you have like a flashlight. But here we don't talk about flashlight. We talk about something that is supposed to be like spreading light all over and all around, like evenly, more or less. But here it's like it's not that. It's like the light stops at straight lines. So this is strange. You see the same thing over here. You can see that the light, blue light, is like forming like just a small curve like that. It doesn't go, and you see also that the white light also forms straight lines. So of course we just like we are using the pose option, just to freeze the picture, at one split second, so you can get like crazy forms. But but too many times to my eyes, too many times do we see those straight lines and square shapes, and that seem to stop the light. So um, this is the first observation. Of course, we cannot jump to conclusion for now. You see, the light is being like encased like that, but we don't see anything that does encase it. Now check it out. Let's think. You know, this this type of vortex that we see in the stars. I'll bring back the videos of the stars where you can see that best in an instant. So this like type of vortex remind us of what we call here on Earth tornadoes, or whirlpools, in the water like that. Okay, even though it's not this, but it reminds me, that shape, like that vortex of water, of air, going up and down. Now the thing is that, check that out, very interesting. We know that the tornadoes form according to the encounter of cold and hot air together. I don't know how it works. I don't even need to know how it works at that point. But I know that hot temperatures and cold temperatures are being, mixed up, do collide, and this is, one of the reasons why, tornadoes form. Okay, that we know that. Now, about the whirlpool, you know, same type of phenomenon into the water. What does he say here? When two currents with different temperatures and speeds collide, they are forced to turn and swirl around each other, creating a rotating vortex, whirlpool. So here, in the other example we have of what those stars remind us of, we see that also temperatures play an important role in the waters or in the air to create either whirlpools or tornadoes, which means vortex. Now we see the stars, and we see that it looks like, it appears to be some kind of a vortex that goes up like this, like in a cone shape, form there. But again, we don't know where it is. Just looks like it, according to our first observations. So now check that out. We have to understand something, is that stars also have temperatures, different temperatures. So we can define the temperatures according to their colors. One color, one temperature. Different color, different temperature. So I do not know for sure if these temperatures are actually differences of, degrees of heat, you know, uh, among themselves. Or if it's just like like LED lights, sometimes you have like 4.5 thousand K is like daylight, and then you have cold light is 6,000 K, and then a warm light it's like 3,000 K. But actually we are using the terms cold, warm, and day to design, to indicate a color. because the LED light, doesn't have, doesn't have any warmth, so it's not cold or it's not hot. It doesn't have any temperature really. So I don't know if it's that on this that same principle that that define the temperatures of the stars or not, because it's all fresh. I just like understood that like an hour ago, so that's why I wanted to share that with you. So again, differences of temperatures create on Earth vortex, tornadoes, and whirlpools. And what we see, in our footage is that there is some kind of a vortex, coming out from that star, the stars there, and that we know that stars can have different temperatures that we can judge, that we can define according to their colors. So now I want to bring your attention to the fact that uh, stars, the way we film them, show lots of different colors and lots of changes in colors and therefore in temperature. That means that when you look at the footage and you go frame by frame, frame after frame, the colors change totally. Imagine. That means you have like 30 frames per second. Okay, so that means every 2 seconds you have a total different color or temperature. So that means that there is like an activity where there's like a big movement of temperatures being mixed together, you know. And I see also that there is a vortex. That means there are those two things, temperatures mixing and vortex. Just like on Earth, temperatures, vortex. So we cannot jump to any conclusion here yet, because all we do is that we think according to what we see with the means that we have. We have binoculars, cell phones, and brains to see with. So for now, I just wanted to expose that to you in order for you maybe to come up with some ideas and help us understand. But this is very interesting. You see, here we have all these colors: green, blue, purple, yellow. It's very faint, the yellow, but you see it. Now you have other temperatures here: blue, green, yellow, purple, and red. Here you have all the green, orange, blue, yellow, purple, and red. 6 colors. You understand? You have cyan, you have cyan, purple, blue, red, and again purple. 4 colors. So this is what I wanted to share with you, uh, because it might. I'm not sure, but if it's enough to say something, to conclude anything. But it seems to me that it we might have something here. Let me just see how I can get that from that screen there. Oh, here it is. Okay. So it's just a first shot. It's just a first taste of what we got. We have plenty of footage. We have many, many more, pictures and videos of stars that show us strange things. And we already passed that milestone long ago, of thinking that maybe the phone can do that. Maybe it cannot. There are sometimes anomalies that are created by the phones, and we see them right away. We see the difference. We see when our phone is influencing the shape of the star. It does sometimes, but not that way. That means it gets blurred. You have the colors that are like totally like fake, like a blue that goes all around like this. So it's the phone that does that. But when we succeed into seeing the details of the stars and its behavior, the phone does not do that. So this is what I wanted to share with you, that there is an activity out there. It seems to us like it is electrical, uh, and it seems to us that, of course, there is a texture behind the stars. That means there is no space, there is no depth. Maybe there is behind that texture. Hey, we don't know. But apparently there is something like solid or half solid, even soft. I don't know what it is. Again, might be anything. Can be plasma. It can be, I don't know. But there is something, behind those stars, and this is not space. So that's the first thing that we have to understand. Then people can conclude and can, by all logic, by all means, that they can understand that this is the what we call the firmament, or the dome, or at least the first layer of it, or something. But still, I'm still prudent. I don't know, because I don't know what the dome looks like. And again, we have some indications in our book that it looks like solid ice. It's transparent, so maybe it's like a field force. Everything is on the table. Everything is possible at that point. But again, the most important thing that we have to understand is, one, that there is no space behind the stars. Two, there is lots of activity around these stars. It's not just like balls of gas, like, hanging in space. That's not true. Three, the stars are much closer than what they tell us. They're not like billions of light years away, because with a cell phone and binoculars, I won't be able to see them that close. Okay, this is a basic logic. Um, Fourth, uh, we know that, how can I put that? We know that there are anomalies, things that, behaviors of the light that cannot be seen here, on Earth. So that means that the light that is spreading from the star, apparently it's from the star, is being stopped by something that is not visible. It's not like a wall. It's just like stops. The light goes and stops on a straight line. So there are things there that are obviously not known, you know, here, and we have to slowly understand what it is. But there is more. We are actually. I'm not maybe going to talk about that now, because it's probably too early. But we have theories of what these things might be, you know, linked to. But it's very very complex, very very hard to understand for now. So it's not worth it, even talking about it yet. So that's it for tonight. I just wanted to, to share with you this information. Just check it out. Think about it. If you have ideas about, what I showed you, just let us know, and we'll be in touch. We'll be in touch. Take it easy.